Okay, I'm Richard Friberg, and this is from my microeconomics textbook in chapter 3, where we're going to be showing how we go from cost minimization to a cost function. Okay. So where were we? We have looking at a case where there's a firm that's minimizing the cost of production using two different inputs, right? It's capital and labor, as we've had before. We can let's do blue say, oh, maybe we should have that as straight lines, right? That's going to be looking nicer. So there's an ISO cost for this firm. So this is called that C1. So this is an ISO cost. So different combinations of K and L that give the same cost of production. And we're going to be looking at the cost minimizing solution for, well, an isoquant. So let's maybe, it's going to be a crowded figure. So let's just call that here Q1. So different combinations of capital and labor that can be used to produce a quantity K1. And as before, we have, a cost minimizing solution that's saying this is so much labor, so much capital. Okay, what's interesting for us now is not necessarily how much labor and capital is used, but rather than that, this quantity is associated with the particular cost. Given how much of the different inputs I'm using, how much, what the wage rate is, what the cost of capital is, this production level, 100 bicycles, say, it's going to be costing me a certain amount of money to produce, 10,000 euros, okay? That is going to be interesting for, how much a firm is producing, where it is ultimately choosing to what quantity it wants to produce. Cost minimization is fine, but profit maximization is where we're heading with firms. Want to see, how much are they producing? So we're going to be wanting to relate the cost, which is the same cost here as for the ISO cost, to the quantity produced. And here we have one combination. Q1 is associated with the cost of C1. So Q1, C1, we have 1 point here on what we could call a cost function. Okay, so we could continue here. We could say, well, at another ISO cost, so for the same wages, same rental rate of capital, but another production level, we would have C2, say. This ISO cost would be tangent to another isoquant. So different combination. Here we're making, what do I know, 300 bicycles. Okay, different combinations of capital and labor that can be used to produce 300 bicycles. That's going to be associated with the particular cost given the wage rate and labor. So say Q2, it's giving us a point like C2, okay? And then finally, but let's do a third one here. So we have a third level of ISO cost, third level of cost, C3. And that's also going to be associated with cost minimizing choice of inputs, this much labor, this much capital, but that's not our core interest now. Our core interest is that this cost minimizing choice is associated with the ISO cost marked by C3 is linked to an output quantity of Q3. So something like this. Maybe we should draw, keep to black here. So Q3 and C3. And similarly, in this way, we can think of, any given number of combination cost minimizing choices. So here, they're on a straight line, but the pointed tangency could, go like this or could go like this. That's not key for us here. The key point is that we can, these different optimal points give us a link between different quantities and what their cost of production is. And we call this a cost function, okay? Cost in euros, dollars, kroner, whatever, of producing a different number of units of whatever good we're looking at, or good or service.